you guys went to the career fair like earlier today? Okay, cool. So hopefully you guys stop by and talk to us. But just to give a brief intro, my name is Saki. I'm part of the campus team at Square. And this is Brian and Jesse, who are our engineers. We're all from San Francisco, and they're going to go into much more of the technical detail. But just to give you an overview, we are looking for interns in full-time. I just put our info up here. This is our email and then our Twitter. So feel free to contact us, follow us that way. I sent around an iPad, so if you guys haven't already signed in, it's really just for your email, so I can keep in touch with you guys. So if you wouldn't mind just putting your info and then bringing it back for it, that would be great. I'll turn it over to you.
So my name is Brian, and I work on what we call our dashboard team. So it's basically just our login website where merchants can go to do kind of the back office stuff. So where they go to check on their payment history, change their settings, view their deposits, basically just kind of run that part of the business. So we're going to talk today about scaling Square. So from where we started as an idea that Dorsey and our co-founder had to where it is now and where we're going. So in the beginning it was basically an idea that came out of a failed sale. Our co-founder does glass blowing, and he wanted to sell one of his pieces to this woman, but she wanted to buy it using her Amex card instead of cash or a check, which was, I believe, the only time the way he connected payments. So he ended up not making the sale. And he was frustrated by this and talked to our other co-founder and CEO, Jack Dorsey. He said, this is really lame. It is the era of smartphones and computers everywhere. We should be able to solve this problem. So the idea was to take a credit card, take the phone that everyone already has with them anyway, and add a little plastic reader. And this allows them to actually process credit cards from anywhere. So I think it took them about a week or two to do a proof of concept, and we spent most of the next year building the initial prototypes and getting the business started. So you guys are probably already familiar with this, but you plug in the reader and then just swipe the card. So the way this actually works is that the white reader actually reads all the track data, encrypts it on the device itself, and sends it into the phone, which then transmits it to our servers using just standard web SSL. So track data might look something like that. Includes card number, expiration date, the name, all that stuff. Sends it up to our servers. So it used to be that everything is in one large application. We used Ruby on Rails at the beginning, and I'm a Ruby guy. I love Ruby, but at some point this just doesn't scale. You end up having problems where, for example, let's say that you are making updates to the copy of the website. So you're just changing some text, and that's in part of the marketing pages. And you do a deploy, and something goes wrong, and you've taken down payments. This should never happen. This should not be something that is even possible. So it was Rails 2.3 application, single database. And we've got something around 20,000 files in the project. It's kind of massive. So it's composed of payment gateway, authentication, installation, et cetera, et cetera, et cetera, et cetera, et cetera, et cetera, et cetera. And it keeps going. So there's all these things that were part of this single application. And eventually, a year or more ago, we decided that this was just not working. So we needed to split this whole thing up into multiple services that each have their own sort of service container, each have their own SLA. So each thing is, some things are more important that they be up than others. So we can more easily allocate resources toward those things that need to be up all the time. So now a payment goes into the payment gateway. It needs to talk to reconciliation, it needs to talk to reporting, bank deposits, et cetera, and this keeps going. So one of the problems that we've encountered in splitting this up, it used to be that it was all in a single application, so it was very easy for the different parts to talk to each other, because they're essentially like, this different class here needs to talk to this other class. Well, that's fine, they're all in the same application, so that's easy. Now, they're actually different services. They may be running on different machines, they might be running completely different languages, and so it became a challenge to actually link these things up in a way that made sense. So a couple of approaches we've used in the past, we started with mostly JSON APIs between these using HTTP, and over time some of these things have moved to using protocol buffers, and that's mostly the direction we're going in these days, but a lot of the services are still JSON, especially those that talk to the web. So, as I said, it's looking kind of complicated. There are things that we've done to address this, and Jesse's going to talk more about that.
So, in the beginning, when there was just a single Rails app, you could just call, like as he's saying, you have one object, you just call a method on that object, and you say like reconciliation object.reconcile, and it works beautifully. So maybe we can do a simple version where we just keep doing that, but we have different services act like the classes. So let's look, if we were to do this, what would this look like? So as a concrete example, this is our receipt. This is for Square Coffee Bar, which is a cafe we have in the office. You get $1 espresso drinks, free coffee. It's really good espresso. If you guys come to the office, you should totally try it. So looking at this, you've got how much you spent, what you bought, information about the merchant. So we want a receipt service to render this. In order to do that, I want to be able to see my receipts, not your receipts. And I don't want you to see my receipts because I don't want you to know what I'm buying. So we're going to have to do authentication. So we're going to have to talk to the authentication server. And that's not so bad. That seems fine. But then we're also going to have to talk to the payment gateway to get a list of all the payments that you've made. But the payment gateway shouldn't really know about you as a person. They should only know about the credit card, the amount. It should be very stateless, very simple, only focus on payments. So we're also going to have to go to your account management, figure out what credit cards you have linked to your account, and then fetch the payments. And then once we've done that, we know all the merchants, we're going to have to get information about those merchants and about the items that they sell to do all these images and addresses. And so now we've got 4 services that I have to talk to before I can even start rendering the receipt. And I have to do them in order because I have to first do authentication, then do account management, then do the payment gateway, then do the merchant listing. And that, each of those takes about 100 milliseconds. We're looking at like a half a second to do this whole thing. And this just doesn't really work for all these. So really all I want is to be able to render this receipt. Why can't I just do that straight away? So, and then the worst part is that after the payment happens, it's going to have to tell the receipt service that a payment happened so that the receipt can be sent over email or SMS or push notification. So that sort of coupling, really tight coupling between one service and another is really not scalable. If we want to add other things that happen after a payment happens, we have to add continuously remote procedure calls for every one of these after effects. So there's 2 solutions for decoupling, and they work really well as analogs of 2 things that you're probably really familiar with: email and RSS feeds. So generally, if you guys all belong to University of Michigan Hackers at gmail.com, and I send an email to that list, the way it works is the email gets sent to Gmail, and then Gmail knows that you guys all subscribe to that list, and so it populates it in all of your inboxes. And so we can use a similar concept here. We have a message bus. It's a central server, and as payment events happen, we publish those to the message bus. Those get sent down, and receipts can subscribe to that message bus, to that topic on the message bus. And there's an open source project called Kafka that we've been using for this. And it's really handy. You can add reporting, and it naturally happens. You just add a new subscriber. The problem is, now we have a new piece of infrastructure that is core and central, and if it fails, everything starts breaking. So if the message bus stops working, or if it gets backed up, receipts don't work, reporting doesn't work, reconciliation doesn't work. So how do we get the benefits of this decoupling without the central server? So RSS feeds are another technology on the web. if I have my RSS feed, as I publish things, the RSS feed goes out, and anyone who wants to follow things that I publish just checks the feed and looks for things after the last thing they looked at. So your RSS reader knows the last article you read, and it says, give me articles after this point. We can do the same thing in our system. Create a feed on top of payments. And then receipts knows the last receipt it sent, and reporting knows the last payment it saw, and they just consume from it. And so now, as long as the payment gateway is up, it has its own feed, its feed is up. So all of the system is centralized in a single surface. And this architecture is really nice for things that are incredibly important to happen immediately after an event. The problem with this is that it's really difficult to handle modifications. It's really good for creations, because you publish an article. But modifications, you now have to maintain a history of your entire feed, of everything that happened. So it's kind of difficult to maintain all those middle states. And it's not necessarily beneficial. So now we can kind of mix the two together. So we have a big payment gateway. I'm looking at our infrastructure now. Payment comes in. We use the remote procedure call to do authentication, because that makes sense. It's a single event. You have to do it on every request. You can continue to use the simple answer there. And then we have a feed here, and we have important things like reporting pulling off of the feed, and reconciliation pulling off of this feed. And for payment events, it's really easy because it's just a creation. Like the payment happened. It's perfect. But then we also can use a message bus off of this feed. And we have lower priority things like receipts pulling off the message bus. And they also have RPC calls to authentication. And you can use this message bus for anything. Put in item updates, which are, you don't want to maintain the history of all the item changes and what the item state was at each change. So you just publish events and say, you know, this happened. It updated the image, or it updated the name. So now that we have all this information traveling through our system, we've got a good, robust system, there's a lot of things that we can do. So just sort of generally looking at some of the interesting problems that we're working on at Square. So one of the main parts of any payment system, any system where money is moving around, is fraud. If you have money moving around, people are going to try and steal your money. So we need a way where we can determine that someone is being fraudulent in our system, is trying to steal our money, is trying to steal money from somebody else. And then as soon as we know that that's happening, we need to be able to shut them out. And one way that we can shut them out is by connecting users with commonalities between them. So if one user is fraudulent, they might have 15 accounts in Square. So if we look at common pieces of their account, like they're using the same card reader, they're using the same phone, they're using the same social security number, we can connect users in our system with each other. And these commonalities allow us to identify a single fraudulent user through algorithms, machine learning, payment data, and associations. And then figure out that that user is connected to all these other users. And kicking out one, we can kick out all of them. These are all, I'm going to go over these cursory, and if we want to dive deeper, we can. Another thing, we know that all these merchants sell items. We know that maybe a cafe sells a mocha. But relationships between that item and other items allow us to get a sense of how items are being purchased together, or that one item is a type of an item for searching. So if you want to search for coffee, a cafe mocha should show up. But in order for us to be able to do that, we have to know that a cafe mocha is a type of coffee. And that type of relationship is not necessarily something that exists in the world. There's not a lot of dictionaries where you can look up relationships between all of these words. So we're trying to develop that to enable us to do search, so that searching for coffee, you can find all of Square merchants who sell cafe mochas, cappuccinos, espresso, all these types of coffee. And for doing recommendations, that if you like coffee, and we can tell that because you bought cafe mochas, cappuccinos, espressos, and you've also bought croissants, we can tell that someone else who buys coffee might also like croissants. And these kind of graph relationships between items, something we call co-itemizations, allow us to help our businesses grow and increase their sales on a daily basis. And the way that we can do this is with my team, the directory team. So this is why I'm pretty excited about it. So this is our Square directory. It's a website, square.com/directory. And on this website, you can see all of the Square merchants near you. But we really want this to be smart. We want it to look at the things that you're doing. All these payment events are coming into our system. And there's a lot of data here. So with all this data, we can start to look at common trends, common places that two people go together, common things that people purchase together. And knowing the places that you go, we can recommend really interesting places for you to go. Helping drive traffic to new merchants, helping merchants increase their sales, growing us as a business and our merchants as a business, and hopefully providing you with interesting experiences that you hadn't thought of before. That was pretty quick. Sure.
All right, so we should go into Q&A, so yeah.
So you said that, was it the Rails that didn't scale, or was it the way you guys were using Rails? Because I believe Twitter's still written with Rails, correct? And it scaled pretty well? Or was it, because it was originally written in Rails?
It was. I believe they moved most of their stuff to Scala,
Okay.
and I believe they're still on there, although there have been some rumblings about them moving more to pure Java.
Okay.
So it's not necessarily Rails so much. There were some architectural decisions that were made early on with Rails that actually do make it kind of a problem. Like you can only really serve one request per process at a time. That's just because some of the Rails libraries, like Active Records, were not really designed to be used for like a multi-threaded environment. And also, before JRuby came along, the sort of most popular Ruby implementation, MRI, didn't really support native threads. So there were a couple things conspiring against it. Java has pretty much already solved those problems. So you can get some of the benefits with JRuby, but a lot of our team has experience with building like cross data center, high availability applications using Java.
Okay.
So that was a lot of the reason we ended up going.
There's also some issues with Rails as your organization grows. It becomes somewhat difficult to see where code is happening.
Yeah.
Ruby's very flexible, which is really nice when you're trying to move fast. But as you start to get to a large size, that flexibility starts to become somewhat of a hindrance because you have different developers developing in different ways. And you really want to sort of standardize so that someone jumping into a project can immediately see where things are. And strictly typed languages force you to do that a lot. And then Java is actually, because it's so strict,
Yeah.
it's really easy to jump in and know exactly what's happening. IDEs also help a lot. Start
Yeah.
around with that.
Ruby is notoriously hard for IDEs that really provide that much help.
Okay.
So you said that when you were breaking the services up, you went with protocol buffers, and I was curious if you also considered Apache Thrift, and if you did, if there were differences between them that you saw, or just kind of what your thoughts were.
Yeah, so the decision to go with protocol buffers is somewhat notorious at Square at the moment. It happened sort of under the covers it wasn't necessarily 100% intentional. We started working on an event framework, the message bus, and it was decided that we wanted to use strictly typed objects in our message bus, which makes sense because immediately you can investigate a topic and you know exactly the type of object that's in there. The team that was working on that happened to be mostly from Google, and Google developed protocol buffers, so they were all very familiar with protocol buffers. Thrift is, I think, equally valid as a message, as a wire format. Thrift has some really nice properties that around RPCs that protocol buffers is a little behind in, and Thrift tends to be a little more open source than protocol buffers, which is still sort of controlled by Google. So I think what we'll probably end up doing is pushing protocol buffers beyond what it does today. And because we have people who are so familiar with it, we can do that. And so I do think it was probably the right decision, but it is somewhat hotly contested at the moment.
Okay, cool.
So you seem to go to similar path as Twitter, and obviously you share key personality. So
Yeah.
are there common methods or either shared architecture?
We don't share that much with them. We actually they just published an article where they went over their basic infrastructure, and we saw a lot of commonalities. And I think some of that is that there's common history within the companies and common personnel. Some of it is also that there have been some common practices that have sort of disseminated throughout the industry about how to scale infrastructure. There is one major difference between Twitter and Square in terms of need. Twitter is sort of, we're both somewhat event-oriented. There's a payment event and a quick tweet. But Twitter is much easier to get into an eventually consistent state where if I tweet out and you're one of my followers and it takes an hour for my tweet to get to you, it's not optimal, but it's not really worth it. If we have a payment come in and it takes an hour to come into your reporting, that's the end of the world. That makes the merchant think the business isn't running, and that's really problematic. So there's two main concepts that come up here. There's ACID and BASIC, if you've heard of those. ACID is a property of databases where everything is atomic, consistent. I and D, I forget what they stand for, but it's all about a right operation. Once it's succeeded, you know that it's there. And base is sort of the opposite, where things can sort of eventually spread out through the system. I think Twitter will be much more comfortable with base, where you can worry about performance and speed and less about consistency. We have to be consistent. So we have to find ways to be consistent and fast. Well,
Well, I guess one question, again, kind of along those lines. Did the need for more ACID properties with the data you have influence the databases that you're using?
yeah, so we're still largely using SQL-style databases. We started with MySQL and have since moved to Postgres, which we're finding has more robust support for a lot of more advanced database procedures. For example, MySQL is O of N for adding a column, which is very slow on a 3 million row table, and our users table has around 3 million rows, so, or had at one point. So there are other data stores that we're investigating and that we were using. On the directory team, we're using some Solr for some of our search and indexing, and that's a little more exotic and eventually consistent. But for payments, we're sort of sticking to your old school hometown aesthetic.
And all that stuff is still currently in a MySQL database. So Postgres is mostly used for new stuff. But for the time being, we're sticking with MySQL because it's just really hard to move that much data off of it. Do you have any questions about other technology or Square as a company, internship program, some stock you might be able to answer?
You guys have any plans for any new products?
I mean, we're always looking to expand our stuff. I mean, so we started off with just an iPhone app, and that eventually expanded into Register for iPad. And before that, we actually came out with what at the time was called Cardcase, and now it's called Square Wallet. And that was just one guy on our team who saw a need for that and decided to just go build it, and it became part of the product line. So yeah, I mean, we're always looking for new stuff, both from internal developers, and if we see something out in the world that looks like something that we should be doing, we'll work with that.
There's a really nice symmetry right now between wallet and register, like buyers and merchants, buyers and sellers. So if adding a third application might be kind of a tough sell. But those products are in furious development. So we're adding features on a regular basis. Register has a lot that needs to be added to make it like the fully functioning POS system we want it to be.
We're always expanding their usefulness. So when Register first launched, it was great for like small coffee shops, but it wouldn't have been great for a restaurant. And so we're always looking to build more features that will enable more and more merchants to actually use it as a point of sale system. So, and same with Wallet, like trying to make it easier for consumers to use, more rewarding. Some of the stuff Jesse was talking about with suggesting merchants that you would probably like. All things like that would be good areas to go.
What is the culture like at Square?
Well, that's a good question. Well, it's very transparent. That's our number one. So every Friday we have a town square where we get the entire company together, and Jack and Keith, who are our CEO and COO, come up and talk about all the progress we've made, where we are in the business. Keith goes over all of the numbers of how much money we're making, whether we're hitting our targets. If we're not hitting our targets, why not? If we are hitting our targets, how awesome that is.
Basically, that same information being shared with the board.
Yeah, all the board slides get presented every quarter. So all of our office conference rooms have glass windows, so you can look in and see what's going on. It's kind of awkward, but you can totally do it.
Another aspect of that is we also have, we make pretty heavy use of email mailing lists, and one of the mailing lists we have is called Notes. And the idea is that every meeting should have notes taken for it and then sent to that mailing list. So, and this includes everybody. So meetings with CEO, like working on new partnerships. A good example of that is Starbucks. When that was first being in the planning stages, we actually, everybody in the company knew about it. We knew about it months before it was actually publicly announced. So to work at a company that has this kind of transparency and that kind of trust is, I think, amazing.
There's also a lot of trust in the ability of the employees. So every quarter we have a hack week where we spend the entire week, every employee can work on whatever they want to work on. And part of that is because we trust that our employees will work on things that are valuable. So some of the hack week projects have turned into real products. Oh,
That was a happy.
oh yeah. So our receipt printer. Getting receipt printer Bluetooth communication between the iPad and the receipt printer started as a hack week project, and now that's out there in the wild. And a lot of them are, if they're not out yet, they're in development. It's taken as a very serious part of what we do as a company.
It's also really fun.
Yeah.
I've done 3 or 4 happy now, and it's always a blast. Like you get to work with basically whoever you want, and for me, it was I got the chance to work with people who weren't on my normal team. So it can be like working with the hardware guys or working with the video team, just sort of whatever you're interested in doing.
Sure.
So the last time I checked, it seems that you still have to use the Starbucks app to integrate the e-coffee for Go member. Is there some issue with that, or actually some thing about the partnership with it?
That is true. We don't have loyalty in our app. There were some technical issues and some business issues that came up that caused them to not be quite ready. They weren't 100% confident in moving it over, and we figured we would wait out until we could develop all the features that we needed to be able to take that on.
The Starbucks partnership rolled out in kind of stages. So the first stages were to do with Wallet, and so it was just San Francisco and Seattle, and then sort of expanded from there. And the scope of it was part of that. So some of the things we left out are, like you said, the loyalty stuff. Another thing was what sort of the signature of Wallet has been, which is to pay with your name. It's the way the flow normally works, is that you go to like Yorio's Gelateria and check in, and then you go and order and say, just put it on Brian. And they'll see my picture and can just pick me from the list, and then it just charges me via the phone. So that experience is not currently how it works at Starbucks. They just use the QR code, which works and was compatible with their existing systems, which is partly why we went with that. But there are plans to move to actually doing pay with your name at Starbucks. So I imagine that other things will probably follow suit.
Yeah, what are team sizes like generally? Or like the number of people that?
So there are large, high-level teams range in size a lot. Generally, it ends up working that a lot of people work in smaller teams just sort of naturally. But my team has about, actually my team has 4 people on it right now. There's 4 engineers, and then we have 1 designer and a product editor. So I guess all told, 6 people. The dashboard team,
We have approximately 6 engineers, and there are a couple designers and product people, but there's also, so dashboard, the team I work on, is actually part of the merchant team, which is probably the largest team in the company. It's like around 20, maybe infrastructure, but largest product team, definitely. So it kind of varies, but like the people I work with day to day, approximately 6.
other questions?
Well, I just want to let you guys know there's some card readers up here. We have plenty more, so if any of you didn't get one earlier or would like one, feel free. And we're going to be coming back on February 22nd to do interviews, so you just have to apply through Ingenious, and then we're going to invite people that way. So we'll send around a messaging, but just want to put it out there.